day 2 of proofs with angle pair theorems based off of parallel and perpendicular lines. So today what we're going to do is we're going to be going in reverse. We're going to be talking about the converse corresponding angle theorem, converse alternate interior angle theorem, converse alternate exterior angle theorem, and converse same side interior. Now, when we talk about the converses, here's the things we have to realize. When we talk about the converses, we have to say that angles are corresponding, for example, and we also have to say that they're congruent. So there's two things they have to be, corresponding and congruent. Then we do the two lines are parallel. So it's going to be very similar to what we did on day 1, except we're going in reverse. So we have to be able to prove that that relationship exists and that that relationship is congruent in order to say that the lines are parallel. Okay, and that goes for a lot of those. Okay, so let's try this. If we look at this, we have angle 2 and angle 7. Well, angle 2 is part of this intersection. Angle 7 is part of that intersection. So when I look at that, the line that is cutting through both of them is M. So M would be the transversal of my two parallel lines, A and B. Now, how do I know that those are congruent? Well, because those lines have to be parallel because 2 and 7 are alternate interior. So what I know then is by the converse alternate interior angle theorem, I know that those would be parallel to each other. Okay, let's try another one. So if we look here, we've got 5 and 13. So I'm talking about this intersection and this intersection. When I look at that, the line that's cutting through both of those is B, so my transversal would have to be B, which would make M parallel to N, and 5 and 13 are corresponding, so this would be by the converse corresponding angle theorem. Okay, let's try another set. So if we look here, we start in, we have angle 1 and we have angle 12. So I'm talking about this intersection and this intersection. A is between both of those, intersecting both. So the transversal would be A, which would make M parallel to N. 1 and 12's relationship are alternate exteriors. So this is the converse alternate exterior angle theorem. And this last one here, I have 10 and I have 13. I'm talking about this intersection and this one. N is the one going between them. So the transversal there is N. 10 and 13 are consecutive interiors. So what I know is I know that A is parallel to B by the converse consecutive interior angle theorem. Okay, so that's how we're going to start spotting those. The key here is we have to be able to recognize which lines are parallel to which. Okay, and also from that, which angles then would be congruent based off one set of parallel lines. All right, so now we're ready to write a proof. So here we go. Let's take a look at what we're given. So in this first proof, I am given that W and R are parallel. I am also given that 13 is congruent to 4. So the first thing I'm going to look for is I am going to look for a relationship to both 13 and 4. So I'm going to use 12. 13 is alternate exterior to 12. 12 is corresponding to 4. But now, here's what I have to ask myself. With W and R being the only two parallel lines that I know at this point, who would be congruent? Would it be 13 and 12 or would it be 4 and 12? Well, the answer is 13 and 12 we know to be congruent. So we have to start our proof there. So what we're going to start off with is we're going to say, hey, 13 and angle 12 are alternate exterior angles. Why? By definition of alternate exterior angles. Okay, next, we know they're alternate exteriors of parallel lines. So I know angle 13 is congruent to angle 12. And that is by the alternate exterior angle theorem. Okay, now that I know that 13 is congruent to 4, and I also know that 13 is congruent to 12. So now I know angle 4 must be congruent to 12, and that is by substitution. Okay, so now we just have to say what it is. So angle 4 and angle 12 are corresponding angles, and that is by our definition of corresponding. Now, here's the key to this. Since I know those angles are congruent in step 4, and I know that they're corresponding in step 5, now we can make our proof statement of P being parallel to Q by the converse corresponding angle theorem. Okay, so that's the key there. You have to figure out which set of angles is congruent to start with based off the lines that are parallel. All right, let's try another one. So let's go through what we know here. I know that P is parallel to Q, and I know that 2 is congruent to 15. And I want to prove the other set. So I need to find a relationship between them. So what I'm going to use is 10 here. 10 is an alternate interior to 15, and it's corresponding to 2. So now I have to ask myself, who is already congruent based off the fact that P and Q are already parallel? Well, the answer would be 2 and 10 are congruent based off of that. So when we start off, that's where we have to start. So we're going to go angle 2 and angle 10 are corresponding angles. And that is by definition of corresponding angles. Step 3, now they're corresponding angles over parallel lines. So angle 2 is congruent to angle 10. And that is the corresponding angle theorem. Once I know that, now I know 2 is congruent to 15. I know 2 is congruent to 10. So now what I know is angle 15 is congruent to angle 10, and that is by substitution. Okay, now once we know that, we need to state what the angles are. So angles 10 and 15 are alternate interior angles, and that is by definition of alternate interior angles. Now, here's where we check. I have them congruent in step 4. I have them defined as alternate interiors in step 5. So step 6 now, I can say that W is parallel to R by the converse alternate interior angle theorem. Okay, so that's how that works. Let's try one more. Here we go. So we start off, we know that W is parallel to R, and I know that 1 is congruent to 16. And I want to prove P to Q, so I need to find that angle that's related to both. Let's use angle 9. So if I look at angle 9 and 1, they're corresponding. Angle 9 and 16 are alternate exteriors. So when I look at that and I ask myself, okay, W and R are parallel, who would be already congruent? And that would be 16 and 9. So I'm going to start in. So step 2, I'm going to define them. So 9 and 16 are alternate exterior angles. Why? Definition of alternate exterior angles. Step number 3 then, we know that angle 9 is congruent to angle 16 because of the alternate exterior angle theorem. Now, we know that 1 is to 16 and we know 9 is to 16. So what that tells me then is that angle 1 is congruent to angle 9. That is by substitution. Okay, now we need to define them. So angle 1 and angle 9 are corresponding angles. Okay, and that is by definition of corresponding angles. Now we take a look here. I've proven that they're congruent. I've proven that they're corresponding. So step number 6 then tells me that those two lines have to be parallel, and that is by the converse corresponding angle theorem. And that is some examples. That's not the end all of how we use them, but that is some examples of how we use those converse theorems to prove lines parallel.